All right. Hi, everyone. I'd like to quickly just remind everyone to check out our house rules for our Oceanside chat. We have Oceanside chats at the Viterbi Startup Garage throughout the year that we make open to our general network population of students and faculty and teams. And then beyond, anyone who's come through the garage, anybody who's spoken. So the events can get pretty big. So please be respectful. I'd love to now present Natasha Stavros. Just a little bit about Natasha. She she's an applied science systems engineer and she's worked at the NASA Laboratory of Atmosphere and Space Physics. She has her BA in Mathematics and Computer Science, and has her MS in Environmental Sustainability. Just a little note on the environmental sustainability is that she has some really cool, I think they're TED Talks actually, on what would you call it? Like fire, what is it called, Natasha?
Well, the TEDx that I gave was on just about sort of statistical uncertainty and decision making, but I also, I think you're talking about the recent video with the Washington Post on megafires and climate change.
Yeah, which, for someone in California, is actually a very topical video to watch. So if you guys want to see some more stuff like that, please check that out. Okay, Natasha, I'm going to hand it over to you.
All right, great. Thank you so much. Today I'm going to talk about wicked problems and how we can use wicked innovation, which is something that I've sort of generated over the course of so I'm going to go ahead and get started. Companies seek to create entirely new markets through disruptive innovation that can change user and consumer behavior. In fact, disruptive innovation is the basis for some of the biggest brands we know today, making innovation and disruption buzzwords in recent history. So often people talk about innovation as a product, a shiny object to be obtained, when in reality, it is the act of innovating, which is really a process that takes time. Yet few people talk about the process to innovate. What is that process? How can we strategically invest our time, energy, and money to change people's behavior while mitigating risks to investment? Here I'll walk you through the processes for innovation that NASA employs to mitigate risks while staying at the frontier of the unknown. Why NASA? Well, changing people's behaviors and their organizational systems is defined as a wicked problem. Wicked problems involve multiple organizations and often face disagreement resolution and require a systematic approach. Specifically, finding a solution that mitigates risks to investment requires system engineering. While technology is thought to be only one driver of change, if designed and applied correctly, technology can enable systematic change for disruptive innovation. For example, a decade ago, most people would not choose to hitchhike with a stranger. However, a well-designed technology disrupted both the sociocultural status quo and policies to provide a tool for strangers to share rides, now a common practice. Arguably, NASA is one of the first information technology-based disruptive innovators in the world, pioneering innovation since 1958. In 1961, US President John F. Kennedy challenged NASA to engineer the first human landing on the moon. Just 8 years later, NASA succeeded, despite having only 30 minutes of man-hours in space. Such a feat required managing 400,000 engineers and 20,000 contractors, as well as obtaining bipartisan support for the 1962 Salary Reform Act to maintain white-collar wages at a level competitive with private sector. Because of this, Science magazine observed that NASA's most valuable feat was not technological, but rather better knowledge of how to accomplish great social undertakings. Thus, Wicked problems are exactly the kind of problems that NASA works to solve. Here I will show you how to scale NASA's processes for innovation to new non-aerospace domains using the Wicked Innovation Framework that I developed as a NASA science system engineer. Before we do, let's look at how NASA innovates. NASA continues to lead innovation to new frontiers in our galaxy and beyond, reaching for new heights to reveal the unknown so that what we do and learn can benefit all humankind. NASA studies how the universe began, evolves, and what will be its destiny, the origin and evolution of the solar system and its relationship to the sun, the origin of life on Earth, and how and why it's changing. So how does NASA mitigate the risks associated with studying the unknown? Crucial to NASA's success is the application of the scientific method to constrain our pursuit for new truths based on evidence and current understanding. This is called science system engineering. What does science system engineering actually look like in practice? It starts with market research conducted by the National Academies of Sciences about what the current state of knowledge is and what is needed to advance it. The National Academies then recommends priority science objectives based on hypotheses to advance systematic understanding. Then NASA begins concept formulation on a discrete, actionable, risk-mitigated plan to collect data and test these hypotheses, thereby advancing scientific understanding of the universe on time and on budget. To do this, NASA uses a tool called the Science Traceability Matrix that traces the scientific method into an implementation plan. We start with our goals, then trace to objectives, testing hypotheses of scientific advancement, and then to an experimental design, including the type, quality, quantity, and collection strategy of data needed to test that hypothesis. Here's an example. Assume that our science goal is to understand how climate change affects life on Earth. A discrete objective would be to determine if drought is the driving predictor of tree mortality or if beetle kill is. To test this, we need to observe tree mortality, drought, and beetle kill, which we can observe from physical observations of solar reflectance off of the Earth's surface, which we measure from an imaging system, kind of like an advanced camera spanning the visible to infrared portions of the electromagnetic spectrum, that we collect over forests across the globe year-round for at least 3 years, observing in the late afternoon when plants are stressed. The science traceability matrix actually follows the knowledge hierarchy, whereby goals align with wisdom, objectives and physical parameters with knowledge, observables with information, and instrument and mission design with collecting raw data. Note that wisdom is an important part of how NASA realizes its vision. What makes this unique is that few discuss wisdom. Some have defined wisdom as accumulated knowledge that enables application of concepts from one domain to new situations or problems. Like gravity, we understand the principles of gravity so well that we can apply them not only in our known environment on Earth, but also to land a rover on the surface of Mars. This definition is not that different from viewing wisdom as applied understanding. If we think of wisdom in this way, we can use the knowledge hierarchy as a framework to scale NASA's processes for innovation to design and develop technologies that significantly alter the mode of operation. Wicked innovation uses the knowledge hierarchy, design thinking, system engineering, and the scientific method to mitigate risks while creating disruptive technology. It is built on the premise that human actions are determined by what we know to be true based on observations of our experience in the world. Wisdom is action informed by values and the patterns of what we know to be true within a given context, based on patterns of information from evidence or data that we have available to us. Wicked innovation transcends any one discipline, whereby in the realm of wisdom, we have disciplines like policy, economics, business, decision science, sociology, psychology. And in the realm of knowledge, we have modeling, domain expertise, complex systems. And in the realm of information, we have automation, mathematics, image processing. And in the realm of data, we have software and hardware engineering, ontologies, metadata, and information security. Because it spans all of these different disciplines, the success of wicked innovation relies on system engineering. In 1991, Kevin Fosberg and Harold Moos created the V model to describe project system engineering. Since wicked innovation systematically engineers change in actions, we can map the knowledge hierarchy to the V model. The first step is to map the concept of operations. We can do this by deploying the PEST model. In 1967, Francis Aguilar, a Harvard business professor, defined the PEST model, stating that changing the current business environment involves understanding it as it relates to policy, economics, sociocultural factors, and technology and tools. Thus, to identify the product for changing the current state, we must understand the informed actions by the people and the processes that govern them. Which means we need to architect our system by collaborating, communicating, and documenting a shared vision and implementation among the stakeholders of the system you want to change. According to Kenneth Curtin, a lecturer at University of Southern California, this includes working with people in the political, business, management, and technical sectors, which is really the PEST model. So how do we find a shared vision among our stakeholders? We can't just ask people because, as Steve Jobs once said, people don't know what they want until you show it to them. So how do we figure out what people want when they can't or don't articulate it? We need to examine the behaviors of the people in the system we want to change. Why does this work? Well, the human brain actually follows the knowledge hierarchy by systematically processing data to motivate the actions we take. As you sit here, you listen to me, an action informed by you knowing that I have something to tell you, which you learn from information provided to you as words and sentences. That your brain processed from data, photons reflected and absorbed off the screen, phonons, excited periodic elastic arrangement of atoms or molecules vibrating from your speakers and tickling the hairs in your ears. Researching why and how people do what they do enables us to design specifically to create the value add to the existing system. For NASA, the value add is validating that our integrated system can provide data to advance the current state. More broadly, this is commonly referred to as return on investment. Importantly, the return on investment is defined by stakeholders' values, hence the importance of understanding their current behaviors, which illuminate those values. Once we understand what the product needs to do based on what constitutes value add to the existing system, we need to define the requirements, which we can inform using a technique called process knowledge mapping. Why? Because our value comes from helping the brain scale the knowledge hierarchy. Once we have a well-defined problem and product, we can build it and verify and validate its value add using our defined metrics of return on investment. And then by demonstrating that value add, we can refine our concept of operations and grow the functionality of our system. This is the process of innovation to create disruptive technology that mitigates risks and increases your chances of investment. Now I'm going to give you a real life example so that it doesn't seem so out there. The example I'm going to give is data system engineering and management. So it's not a NASA mission system because I would think that you assume that NASA knows how to design a mission system. I wanted to show you an example of how we could apply it in something that wasn't specifically putting something up in space. The specific example I'm going to use is imaging spectroscopy environment on the cloud, or ImageSpec, which is a project that I am managing right now. And I just want to sort of take a second to call out that, this work is not just me. It takes a team. System engineering, in general involves a team. And so I want to acknowledge all the other people who have helped in the process. So for ImageSpec, first we had to sort of map our concept of operations, applying the PEST model using a change traceability matrix, which you can see down here. And the change traceability matrix is something that I created to translate the science traceability matrix into the change that you hope to see in the system that you want, or that you're working in. So a little bit of context. In 2017, the Earth Science Decadal Survey recommended 5 Earth observations to change the current understanding of the Earth system. They called these designated observables. One of them was called Surface Biology and Geology, or SBG, which would provide open data access to global, regular, repeat imaging spectroscopy data. So to give you an idea of what this data is, you can see it here. This is called an image cube. On the top, you see basically what you would see in RGB if you were looking at the Earth's surface. And then as you look down the cube, you can see how we can observe that Earth's surface in a full range across the electromagnetic spectrum. SBG provides the chemical fingerprint of the atmosphere and the Earth's surface, which really ultimately results in dozens of information value added products. So you can see that here in this figure, right? On the left, you can see that from 400 nanometers out to 2,500 nanometers, got a little cut off there at the end, we can see sort of this full spectral signature. And based off of different peaks in that spectral signature, we can infer different the different chemistry that's on the Earth's surface. This is a really powerful measurement because not only does it give us the chemical signature of the Earth's surface, but it's also backwards compatible with data that we have over 30 years. So what you see in the lower right here is multispectral. We have a very long time series of looking at the Earth's surface in this way. And so what we can do is we can take the data here and we can actually sort of convolve it or find the averages to create these sort of broad bands here. And so we can not only get more information today, but we can continue a long-term record. One of the biggest challenges is that we have barriers to use. And those barriers are that it is really big data, huge data volumes, which can be very expensive. It also requires a lot of processing expertise to use it. It also is really relevant to a very broad range of users. So different types of users, from field scientists, remote sensing experts, down to educators and students, or even policymakers. And it can, and is relevant across a range of disciplines, including hydrology, weather and air quality, terrestrial ecosystems and natural resource management, earth surface and geology. And so the question really becomes, how do we design a data system that maximizes the utility of this data to as many people as possible? Well, we have to look at the current system that exists. The current system, we basically, we collect a lot of data. So NASA missions make quality data publicly available. And to do this, they use the 80% algorithm solution. So they say, hey, this algorithm is going to work 80% of the time. We feel confident about it. We can, process our data this way, and we can turn it into information and feel good about it. They do hold themselves to very high quality assurance, and they do have scalable compute. And so they're able to process really large amounts of data, and they're able to do it, all over the whole globe over a very long time series whenever updates become available. So these are some of the strengths of the existing system that they have. The challenge is that it typically only provides data to a certain point in the transformation from data to information. So it really goes from this like very basic data that the sensor collects, and it processes it through to level 2 data, which really doesn't actually help us answer our scientific questions and address the objectives that we have for our mission. And so that really falls on our scientists coming sort of down the pipe and our researchers later. And this is really where the opportunity for improvement resides, because this current system is the way that it is, it results in something that we call sort of the 80-20 paradigm, which is that researchers spend 80% of their time processing data and only 20% of their time analyzing it. And so this really inhibits scientific advancement. So if we put that into the change traceability matrix, just as you would put something into a science traceability matrix, you can kind of see a clear traceability from the way that we currently do things, and the opportunity for improvement with this new mission coming online. And so the question then becomes, okay, so now we've got this goal to flip the 80-20 paradigm that's inhibiting scientific advancement. And we can start to say, okay, so let's define a product from that. Let's define a discrete objective. So we would say, okay, the system that we're trying to create should expand the use of existing imaging spectroscopy data. And it could develop an on-demand science data system for distributing standard and custom level 2 products, right? So the old system enabled us to provide standard products, but not custom products. And so custom products would allow people to actually get to information to analyze their specific challenge more quickly. And when we do this, we need to take advantage of current NASA skills, quality assurance, such as provenance, and reproducibility. So for those who don't know what provenance is, it's basically ensuring that nothing happens to the data. It's kind of like in CSI, when you're saying something like the line of evidence, you can't break the line of evidence. That's what provenance is. And that it should also have scalable workflows. So from that, we know that we need to develop a prototype, and we need to test the return on investment of the system, and that we could do this for a subset of expert and non-expert users. So we decided to sort of strategically pick which users were most likely to use a data system as being our field scientists and our researchers and remote sensing experts. And we also had a scientist who was really eager to work with us. So we focused first on the terrestrial ecosystems and natural resource management use case. Now that we know who we're going to build this prototype for, we went the next step to actually map the knowledge and processing workflows to help define the product based upon what actually constitutes value add to the current system. So from that, we actually collected user stories across use cases of the different processing steps and pain points mapped to desired functionalities. And the reason we did this was it's an exhaustive process. It's a lot of time and effort up front, but it allows us to prioritize the functionalities of the system and what we need to create based off of the frequency of the need. And it also enabled us to identify the metrics for return on investment of our system so that later, when we go back for more money, we can show them exactly how we've addressed their needs. So this process resulted in 3 use cases that we needed to generate a standard product. We needed to allow people to have a standard product with some customizations. And then we also needed to allow people to create entirely custom products, right? It also helped us to identify our metrics for return on investment. So we needed to reduce download times. We needed to enable easy provenance for reproducibility, even for the entirely custom product. And we needed to provide a scalable work environment that did not require a heavy lift from science users. So from that, we were able to define our product requirements, which you can see here. It's almost a 1-for-1. This first box here, these are our 3 use cases. And then these other sort of high-level product requirements are about delivering the value add or the return on investment that we identified would make it worthwhile for users to use our system. And then from that, we actually map our user workflows to system components in the concept of operations. This is really tiny on purpose because I don't actually want you to read it. I really just kind of want to demonstrate that this allows you to understand the functions that a user would trigger within the system that you have and to define design requirements for how to build the system that you want. So then once you have that, we can apply a hybrid management approach. I know in software engineering, a lot of people are really happy with the agile framework. I actually advise against that, especially if you truly want to system engineer a product that's going to add value. And so we used a hybrid waterfall agile management framework. So the waterfall says we know what's going to add value. We're going to have that start at the very top and sort of waterfall or fall into our schedule. And then the agile part comes in because we say, well, we also don't have to define our whole system up front the same way we would have to define, let's say, a spacecraft. And so in doing it this way, we can actually build and test the value add of our prototype before we expand to the larger SBG data system. Of course, if we expand, we're going to open up and we're going to have to cater to all of these different types of users that we had excluded in our original prototype, as well as other disciplines. And so with this is going to be a lot more functionality that we're going to need to add. And so we will need to prioritize the functionalities based on estimates of anticipated impact of service. So what you see here is a quantitative framework that I created on another data system where we basically combine in-depth, very detailed user surveys with a sort of very quick and easy user survey that could be sort of broadcast out to hundreds of people. And so if you do this right, you can actually say, of the people I interviewed, what kind of persona do they represent? And then in the broader survey that you see down here, you say, and how much is that particular persona representative of all of the users that I'm going to have, right? So, and then from that, you can sort of bring them together in a quantitative way to look at the anticipated percent impact of a given service. This can be really powerful because it can inform prioritized development of services that add value to the most number of users. And it can lead to sort of very robust and traceable requirements and inform your business model. So the cycle continues. We can then expand out and we have to go back, redefine pest, go down through our requirements and so on and so forth. So with that, I'm going to end with some concluding thoughts that innovation is a process. It's not a product. Wicked innovation uses principles of design thinking, scientific methods, system engineering, project and program management, leadership, and ethics. It is an iterative process, so it can be used at any phase of project lifecycle and at any level of product development. And it cannot be done in a vacuum. It requires collaboration, and that's really essential to building success and getting buy-in early. So with that, I think I'm done and can open up to questions.
If no one has a question, I have a question. So cool to see the breakdown of the whole framework and how it applies to so many different areas. Really appreciate getting to see that. Have you seen any interesting or not funny, but just interesting times when a framework like this has been applied well and systematically, but then the results were just ended up being not good or funny or wrong or something?
I have not. So I've just been developing this framework, and I'm in the process of getting it sort of very broadly published. I can say that I have used it on about a dozen different projects, and I have never seen it fail. And I see it all the time when I go to other talks and I hear other people talk. I'm like, oh my God, that's wicked innovation. If only they knew. And so like, I haven't actually seen it fail. So, but again, 12 is a pretty small sample size. So I would actually put the challenge out to all of you and say, try and take this framework and see. I think it's a robust framework, and there's a lot of confidence behind it. But the only way we'll know is if people start trying to do it and it doesn't work.
Cool, nice, thanks.
I have a question, Natasha.
Mm-hmm.
So, when you approach things in these very systematic ways using models, for instance, like the pest model, you're reliant on kind of gathering very good usable data for every facet of that model. So for instance, what would you say to someone who was trying to kind of innovate during a time like COVID, where using the pest model and thinking about politics and how kind of politics are often behind and are desperately trying to catch up when it comes to, how they're approaching and what the process is for that. How is it at all possible to continue using the very structured model, not being able to gather a portion of what you were originally setting out to do? What kind of advice would you give to somebody in a situation like that?
That's a good question. So I would just say that to sort of step back and extract or sort of extrapolate what you're calling data, right? So there's discrete data. There's the things that we can go out and we can measure. There's also sort of intuitive data. So very often the first place people want to innovate is in a system that they already know very well. And so really the thing that I'm advocating for them to do is say, okay, so what policies apply in that system? And if they don't know, can they partner with somebody who at least understands it? So I'm going to use Tom as an example because I know Tom. Tom's interested in drones. Okay, so what are the policies associated with flying drones? And using drones both in a commercial space and maybe in a public space. So let's say how firefighters are using drones. What are the policies associated with that? And if you can't answer those questions, then you could design your system and then find out that you can't actually test it or that no one's going to adopt it because you didn't consider that up front. So I would really encourage you to do the research on it. Now think about Uber, right? I used Uber as an example, although I didn't explicitly call it out, with the app for sharing rides. Now, they may have considered beforehand, what are the current policies in play about sharing rides with people? And they'd say, hey, there is nothing except for maybe taxi drivers, right? And so they're only considering maybe these policies exist, but they only apply to taxi drivers. So we'll just design this app so that, they're not necessarily taxi drivers. And they may have considered those design. I'm not a part of Uber, so I don't know what was a part of their design process, but they still had to consider that if they hope to have any kind of adoption. And what's interesting about something like Uber is that they actually were so successful from a prototype and into a full-scale deployment that they've actually gone and changed the policy. So the policy caught up. I don't know if you remember when Uber first started, but you weren't allowed to go to the airport because taxi companies had the monopoly on airport rides. Right. And so because they sort of designed this technology and it was so useful, people sort of forced the policy to catch up. But you have to consider it. Otherwise, you won't even stand a chance, I don't think.
Cool. Is there one particular part of the framework that you provide through the WKID solution that you would say is the most taxing or time consuming or the one to not underestimate or overlook?
Yeah, so that's a really great question. And for me, it's all of the upfront work. So do your homework and populate the change traceability matrix. And actually, if you take the quiz, it will help you to fill in the change traceability matrix, and it will actually give you the exact questions to ask yourself to find the answers. So that you can be prepared. And the reason why I say, one, it's a lot of work because usually you don't have all the domain expertise. So you usually have to do a little bit of research. You have to find somebody who understands it, maybe a couple people, ask some really good questions and shape that. A lot of people want to jump straight into building the prototype. Especially like these, really smart people in data science and, tech, they want to jump straight to building the product, and they'll do it, and they'll do a great job because they're really smart and they know how to do that. But then they hit this wall where they can't transition that, and no one will adopt it, or very few people will adopt it, and then they can't get it sort of more widely adopted. So I would just recommend that you spend the time in the upfront to understand who your users are, who your investors are, what are their driving motivations. And this will also help you when you go to have conversations with them to frame what it is you're selling to them in the context that they actually care about.
Natasha, it's so well said. And for those who have taken part in any of our NLA programming or Viterbi innovation program, this is what we call customer discovery. And it's one of the emphasis in our programming. So thank you, Natasha.
Oh yeah, the I-Core program does not skimp on the customer discovery. And actually, Tom could tell you all about that because that process and had to do, how many interviews is it, Tom? How many customer discovery interviews through the I-Core program?
So you have to do 100 in-person customer interviews over the 7-week period, and then they break it down to being 15 per week. Otherwise, they basically kick you out. So you get deep into it. Such a true point.
Rebecca, don't go. I think you might have had a question. Come back.
Yeah, no, I have a question. So Natasha, you mentioned that you used a hybrid approach between waterfall and agile. And I'm curious if we can get into a little bit more of the specifics of what about agile works, and then what about waterfall works specifically for the way that you were using it.
Yeah, that's a really good question. So waterfalls, the strengths of waterfall are really the upfront system engineering and management, right? You go in, you do all that upfront homework, what your customer discovery, you really understand what their needs are and their requirements, and you sort of build it into what you're going to do and the timetable that you're going to do it. And you think in advance, okay, how can I do like sort of a minimum viable product and then build out the functionality through time? And it's a very systematic process. And that's what I really like about waterfall. At the same time, waterfall is, at least my understanding, it really came from sort of disciplines more like aerospace, where you get one shot. You build your spacecraft and you launch it and it goes up into space, and you can't go just like replace a part. And so it's very, it's kind of built for that one time, really low risk kind of method. Whereas agile was built to say, hey, actually software engineering and data science is changing so fast all the time. Let's just be really agile so we can adapt and be really quick. My problem with agile is that it doesn't do the upfront homework. And to me, I just don't see, you're just going to be constantly in this evolution state, and you're never really actually going to make a sale to a seasoned investor that way. I can't imagine any seasoned investor being like, oh yeah, look at this startup tech company that's just so quick and they can just change based off of whatever I say in any given moment, right? That doesn't put them at ease. That makes them nervous that you don't actually have a vision for what you're doing and that you can stand behind it and that it's based on research. And so it's actually sort of more risky. And so that's why I prefer a more hybrid approach. The other reason why I don't like the 100% agile is that I think it's actually extraordinarily time consuming and distracting. Like specifically Jira. I don't know if anybody knows Jira, but Jira is like so cumbersome. you know, and so I kind of like this hybrid approach where you have sort of a general waterfall and then you let that waterfall kind of come into these sort of more agile sort of planning increments and sprints that you can do based off of troubleshooting the problems as they come up. But you still have that bigger framework from the onset.
Makes sense. Thank you.
Great question, Rebecca. Anyone else in the group have any questions for Natasha? There was a few slides that you went through so quickly. I don't want to like have you bring them back up, but I'm trying to remember because I wanted you to speak a little bit more on, you know, like, so for instance, the V model and how you integrated WKID into that V model. I had a question somewhere along the lines of like, maybe just like, can you, yeah, thank you. I think, so when it comes to really kind of like, so for instance, this is everything that it takes to kind of from like ideation all the way to validation. How could you use what you collect in the V model to put together a very compelling deck for investors? Like what parts of these would you suggest are like, so because this is all very process and data driven, whereas investors are very gut and feeling driven. And like, how can you translate something like this into a compelling pitch deck for an investor, I guess is my question.
Yeah, and I think that goes back to sort of the comment that I made about customer discovery. And let me see if I can. So to me, the step that is most under represented out there is this first step. It's the wisdom step. And I would say that that's where their gut and feeling is coming from, because they have a sense of understanding of the world and how it works based off of their expertise in investing in that field for a long time. You know, they have a general, I mean, I'm thinking of Shark Tank. I remember this specific example on Shark Tank where these two twin brothers were like trying to sell a password keeper, and you know, like all the investors were just like, they really knew in their, like there was a couple of them who knew in their gut, Mark Cuban in particular, oh, I've done this before and information security is so key and crucial, and how are you going to secure that? And they didn't have answers for any of those things. Yeah. Because they didn't fundamentally understand what was going on right here. And so I would say that if you've done the upfront work and you really understand the system, you're going to be able to speak to your investor, your stakeholder sort of gut instinct and the way that they understand and know it to be true.
Do any of these like items, so, you know, sometimes when I look at like a perfectly distributed model like this, I know that they're like, obviously it's not 100% accurate, because like if it was like, let's say if it was like a colored model, like the W might be 50% of the top left corner of that V, and then maybe like K and I would overlap in some way and have like a kind of a Venn diagram of situation. So would you say that like if you're just taking the W aspect, right, and how much information you have to get up out front, would you say that you end up going back to that from any of these other processes? You know, like once you're down into your workflow development, you might learn something a little bit more, and then, you know, you don't just keep going, you kind of make your way back up to the W. Like, is there a ton of overlap? Yeah. Like, how would you speak to that?
Yeah. Yeah, that's a good question. So I would say that, you know, once you're sort of down here in workflow development, you really don't want to be going back and rehashing your requirements. Now, can requirements be rehashed? Yes, but you should, like, and this is kind of why I have a problem with the agile framework, to kind of go back to Rebecca's question. You shouldn't be rehashing your requirements so frequently that, you know, you don't really know what it is you're building towards. You know, and especially if you're really trying to do something innovative, that is going to take time. And you do not want to have a system where it's changed so frequently that the work you did 2 years ago is no longer relevant, right? So you want to have that core set of requirements that doesn't really change. You may refine it, you may sort of come back to it and make sure it's a little more specific, but that general core set of requirements isn't really changing. So I would say that, you know, yes, there can be some sort of leapfrog backs where you might go back and iterate, but you really want to and again, right, when you come all the way up, you go back out. When you're building out your system, you've built up your prototype, you do go back to that and ask yourself, is this still relevant? You know, so there is always like a time where you come back and you are still doing and constantly growing and evolving. But I would say that if you really want to do something that is groundbreaking, it's going to take you time to do it. You really want to make sure you've done, you know, that customer discovery up front. You have a really good set of requirements, and don't make this set of requirements so exhaustive. You know, like the first set, your what we would call level 1 product requirements, or the requirements that are just like enabling you to accomplish this thing. Remember when I showed you, wait, hold on, let me go back. Is it here? Right? This was like, these are my level 1 requirements, right? For this system that I'm using to kind of revolutionize and change the way that NASA does data systems and building the prototype for it, right? These are my use cases, and these are the additional 2 requirements that came out of providing return on investment. So it's not exhaustive, but these aren't going to change. Right? They may get tweaked, we may refine them, but they're not going to change. And then I'm just going to jump back over to the framework. So make sure you do this part up front. And the same thing with the process knowledge mapping. Process knowledge mapping is an actual thing that we do. And it kind of hits on the comment that I made about like, why does wicked innovation work? Well, because your brain actually is already doing it, right? Process knowledge mapping is saying you as a domain expert, your customer that you interviewed is a domain expert. They really know how something works. You're mapping their knowledge and the processes that they rely on in a way that you are baking it into your system. And so that when you get back over here, you've kind of already built the verification part into the system that you're doing. Because you're sort of just saying, okay, does this match here? And so this is really the foundation. And if you don't have this will break, right?
That actually leads me to my next question, which was that, so earlier when you were kind of going through the process with the business that you're involved in, you were mentioning what you guys were building was for, a variety of users. Like, I don't know, like 5, 10, 15 people long, in all of these different types of disciplines. So, oftentimes, especially when you're, you're using like lean methodologies for startups, like something like considering all the types of users is a bad idea, because oftentimes like users might be contending for their needs or functionalities. And so then, you can't build something for all people. So obviously, when you guys were making the decision for your business, you thought it was very important to be able to, because what you were doing was innovating an entire space that already existed. Whereas if you're building something maybe new, or you're just kind of like breaking into something, it might be better to just take a single vertical. What would you say to that? And then does that still allow for the V, and then maybe you can bring in more users when you make your way around and add like another set of users and grow in that way?
Mm-hmm. Yeah, and I would say that oftentimes there's products that are created and then we don't fully know how they're going to be used until later. And so, like that's kind of why I said that hybrid waterfall agile framework, because waterfall is really great for upfront system engineering, and at the same time it's a dynamic world. And so you need to have some ability, we're not going up into space where we're in a vacuum and we can account for X, Y, and Z and the amount of space debris and blah, 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 right? We live on Earth. And so it's going to, you need that sort of dynamic and agile ability. And so what I would just say is that, just sort of try to be mindful, right? Nothing can ever be perfect. And I'm not trying to present this framework as, sort of this is exact rules and the law of the land. And if you don't follow it exactly, you're gonna fail. And, perfect is the enemy of good. Sometimes you just have to say, I've done 100 customer discovery interviews. I have a really good sense of what's out there. And from that, I could sort of maybe categorize my users into these 5 categories. And if I could focus on this particular user first, then I know I will have met 40% of my potential market. And so I'm actually going to kind of come back to this particular slide, which is this framework where, sort of your customer discovery interviews. That's what you see here in this representative. You do a bunch of in-depth interviews and you sort of break them up into sort of representative user personas, which, you may only have like 5 or 10. And then from that, you could do a little bit more market research. Now you could send out a survey if you have that kind of mail distribution. If you don't, you could just kind of look online and do some research about those different kinds of people and who's out there, so that you can kind of ultimately say, okay, these in-depth interviews have given me my use cases. And this tells me what percentage of the population or what percentage of all of my potential users does that particular persona represent. So then you can kind of combine the two to say, okay, well, I'm going to focus on this one user persona that represents 40% of my population, and what are their specific use cases. And then as I develop out the system and I've verified that it actually adds value in that use case, now I can start to expand the system and say, let's go back and build out the system, build out additional user personas and see how it works there, and keep going until eventually you break and you say, hey, maybe now I'm trying to get people to use my system when it's not the best thing for them functionally. And then hopefully by then you're, Microsoft, and you're a massive giant and people have to use your system anyways because you forced them into it.
Right. Your brand is so big that people just use it and don't really understand exactly why.
Or know that there's something that could actually meet their needs better.
Right. Right. Well, look, there's still a little bit more time. If anyone has any additional questions for Natasha, please take the quiz that is in the chat. And also, Natasha's been very kind to open herself up to office hours for our VSG resident teams. And so we'll be in touch with the links for her times, her availability. Thank you, Natasha. Thanks for coming back. Thanks for letting us record. It's so cool what you're doing. And I think that from the perspective of the garage, where, it can seem a little bit wacky and nebulous and difficult. And, like people are pulling their hair out, just trying to get people to believe in them. Having something so concrete to hold on to, I think is a really nice way to approach doing something that's kind of out of the traditional path, right? Something totally. Like a touchstone. So thanks for coming.
Well, thank you for having me. And just sort of my final words of wisdom here are, nothing's a rule. It's more like a guideline. So just keep that in mind. They're just guidelines to help you.
Thank you. Have a great Thanksgiving. Bye, everyone.
Bye. Thanks a lot. Thank you.
Bye. Thanks, Natasha.